Hi guys, and welcome back. Here we are now going to really take a dive into this calculus story. I've got 2 points again here as usual, A and B, and I just want to go through one and the same function. I don't want to change functions. I want you to keep on relating to this function here that we started with. So what I need you guys to understand at this point is that once again, I've got point A here, and the x coordinate here will label it x because we don't know what it is, okay? Then there, we can see if I were to take a straight line, maybe I should probably do that. It is not really straight, but it shall be straight. So if I were to put up a straight line here, okay, I think it looks straight. I don't know what you think. Then what I'll have now here is the coordinate x plus h. Now, I want us to observe what's going to happen, okay, as the distance between these 2 points, okay, and this is the distance h, okay. The distance from here to here is h. That's why we have x plus h here, remember from the previous video. Now, I want us to observe what actually happens when the distance h decreases and eventually becomes 0. In other words, it comes down here. We no longer, in other words, now have a distance. So let's take a look and see what happens. Now, at this point, before maybe we start with that, here's the tangent. Okay, this is a tangent here. It's a tangent. And you can see it's a straight line. A tangent is a straight line, by the way, and it has its own gradient. And in this case, we can see the slope of this tangent is what? Is positive. Obviously, if it was going this way, this side, it will be what? Negative, okay? Maybe I should draw even a line there and show you, yeah, this, let's assume this is also a tangent and it touches the graph at some point here. And maybe let's draw another tangent here, actually just parallel to the x-axis and actually lying on the x-axis, okay? And this one here should be somewhere there. And I think that will be fine. Yeah, that will be fine. So let's have that. And now let's get to that part where I said I want to show you what happens as h gets smaller and smaller to a point where it is now 0. So I'm going to take this point B, okay, and I'm going to decrease that point, okay, well, to just move it around. So if I take point B and I take it down, down, down. Remember, as I do this, h is becoming smaller and smaller. You see now, h is becoming smaller, and we say actually h is approaching 0. Okay, so we go down, we continue. Okay, I don't know what is going on here with my pen. Okay. Yeah, technology is getting the better of me here. Whatever I selected, okay, then. So you can see h is going down, down. And as this happens, guys, actually, the gradient between A and B is becoming almost equal to the gradient of the tangent. And actually, as h now gets to 0, okay, we can see actually now, you see point B now is actually touching on the tangent. And you can see now as h now gets to 0, as a matter of fact, we have the fact that the average gradient now is actually equal to that of the tangent, okay? I hope you get a sense of what I am actually trying to bring out to your attention here. So that being the case, guys, as h becomes 0, in other words, the distance between A and 0 becomes really nothing. I mean, A and B gets smaller and smaller and smaller. Remember the concept of the limit? I hope you can now start to relate this to that. then we can see that actually this gradient, the average gradient, is becoming almost the same as the gradient of the tangent. And as a matter of fact, when h is 0, it does equal the gradient of the tangent. So we're going to represent this as a limit. And this is where limits come in, right? We're going to say, well, the limit as h approaches 0. Remember, we have already established that the point there is the change. Okay, maybe I'm not writing on the right spot here. Should just go down a little bit. So we want to say the limit as h approaches 0, the limit of what? F of x plus h minus f of x. Remember, this is just the gradient. In other words, the limit for the average gradient of the function, and remember we have found this in the previous video, the general form of the average gradient, as h approaches 0, okay, is actually the gradient of the tangent. Is actually the gradient of the tangent. Now, we have a nice name for that gradient of the tangent, and that nice name is, well, the derivative of the function f. Okay, that's what we say. Now, that being said, this is actually what we call in mathematics, this thing is what we call first principles. That's what we call it. Now, you use first principles basically to find the gradient or the slope, if you like, of the tangent line to f at any point, of the tangent to f at any point. That's one. We also use it to find the slope or the gradient of the function itself at any point. And we also use it to find, obviously, the instantaneous rate of change for any point on f. Finally, guys, first principles is actually used to find the derivative of f at any point. Now, one thing that I would like for you guys to note before I close off this talk in this session is that the gradient has a tendency to change depending on the position, okay, of the tangent. I think I said that right. For example, here, if the tangent is at this point, we know that gradient here is 0. So that means we can expect also the gradient of the function to be what? Exactly, to be 0. Here, it is negative because the slope is negative from just knowing, from what we know regarding the equation of straight line. So in this sense, we are saying actually it is decreasing. Okay, so let us just write this or say it nicely. Okay, if the graph is increasing, you can look at the parabola. Here the parabola is decreasing this side. And we know that it is decreasing because as we move from one point to another, the values of y are going down. It is decreasing, okay? And then as we move along, okay? So what is happening here, x values are increasing, but the function is decreasing. And then as x values continue to increase, when we come here, the gradient is 0, okay? And then when so that's the turning point. As we go up, what happens? The gradient, we see the function, the values of the y are increasing. And then what happens also is that the gradient becomes positive. So basically, the positive gradient is associated with the increasing part of the function, whereas the negative gradient is associated with the decreasing part of function, and the turning point is associated with the gradient of the tangent being 0 at that particular point. I hope you get this, and it will take us together through a nice journey as we sail through. In the next video, we'll just have a look at an example where we use first principles to find the gradient of a function at any point. Cheers.